Okay, so welcome to BIM Live, which is a community event of BIMLABS Global. Okay, so the topic of today's webinar is structural analysis and design using ETABS software. Okay, so I'll be taking you guys through the benefits of ETABS, benefits, uses, advantages, and disadvantages of the ETABS software. So let me give a brief introduction about myself. I am Namir Mohammed Nasir. I'm a BIM application engineer working at BIMLABS Global. Okay, so before going on to our topic, let me just give a brief introduction about our firm, the firm I'm working at. Okay, so BIMLABS Global is a CAD and BIM service provider. We actually have three departments like BIM training, BIM implementation, and BIM consultancy. In BIM training, we train students, corporates, and professionals. In BIM implementation means if we change the conventional construction design methods into BIM, like building information modeling. We implement the building information modeling in some firms. Then BIM consultancy, we have a team which deals with the live projects, which is called the BIM Studio. So that is called the BIM consultancy. And BIM placements, like I said before, we train students. We also provide 100% assured placement. Okay. So while getting into the certification, BIMLABS is an authorized academic partner of Autodesk. We are also the product training partner of Bentley Institute, which is a parent company of StatPro Software. We are also the member of IGBC, which is Indian Green Building Council, which is related to sustainability. We are also the member of Indian BIM Association. So this is just a brief description about our BIMLABS Global company. Now let's get to our topic. So ETABS. The topic we are going to discuss about today is ETABS. ETABS is a leading design software which is developed by CSI, which stands for Computer and Structures Intelcorp. It's a leader in structural engineering software. ETABS is an engineering software product that caters to multi-story building analysis and design. It provides modeling tools, templates, code-based load prescriptions, and analysis methods and solution techniques. It's all coordinated with a grid-like geometry of the class of structure. We are providing a grid-like geometry. First of all, we are providing a grid-like geometry. Then we are providing the beams and columns. I'll get to that while dealing with the software. Okay. So what are the uses of ETABS software? It's a streamlined design process. When a designer is working with CAD, they can take advantage of the way the software smooths out bumps in the design process. It also provides a simplified communication, a better quality design. It can provide a plenty of documentation. It's also a manufacturing database in which the design data are all saved. Okay. Now, the structural analysis and design. Now, our main topic starts from here. Okay, now we need to do the structural analysis and design using the ETABS software. So let me get to the software. I'm just taking the file that I've saved the software at. So this is the ETABS 20 version. I'm using the 2020 version of ETABS software. So I'm just selecting that software. This is the icon of the software shown over here, as you can see. So I'm just selecting that software. Okay. So this is the info page that opens up while opening the ETABS software. As you can see over here is the latest news which is dealt with the CSI platform. The news that they are collaborated with, all the latest news are shown over here. While going to the left side, you can see the new model, open existing model, and recent models. These are the recent models that I have done already in this system. And for opening an existing model, I have to just choose the open existing model option. For creating a new model, we are just taking the new model option. So here I'm going to create a new model. For that, I'm just taking the new model option. Okay. When selecting the new model option, a model initialization tab opens up. So after giving a set of settings, only we can get into the software. So for that, we need to give a build-up settings. So shown over here is the use built-in settings with, this is the model initialization. We need to first give like setting the units, etc. So here you can see the display units. See, it's shown over here metric SI. As I have set it before, it's shown as metric SI. While downloading a new software, it will be default like US customary or any other. So we need to change it to metric SI. As I'm in India, I'm just selecting it as metric SI and the region for default materials. Like I said, I'm in India, so I'm just selecting the India. There are these set of countries shown over here. I'm just selecting the Indian option. Now we need to provide the steel section database. Steel section database also I'm providing it as India. Now the steel design code shown over here. As we know, the Indian design steel code is IS 800. So I'm just selecting it IS 800 2007 code. And for the concrete design code, it is the IS 456 code that is also shown over here. So this is the model initialization type. First of all, we need to do this, then just go with OK. Okay, after that, we need to set the template. Like I said before, while presenting the PPT, I just said that we need to provide a grid-like structure. So that for that, we need to provide the grid dimensions and the story dimensions. Grid dimensions means which is shown in the plan view, and the story dimensions is the height of the building, height of each story. Okay, now for providing the grid dimensions, as you can see over here, here it is shown as uniform grid spacing. Right, you can see over here, it is shown as uniform grid spacing. And here you can see the number of grid lines in X direction is given as 4. If we need to change the value, we can change it over here. We need to change the value. If I'm giving 5, we can get a 5 number of grid lines in X direction. And in Y direction, it's shown over here. Number of grid lines in Y direction is also shown over here. As I said, grid dimensions we are providing in the plan view so that we can only give it in X direction and Y direction. Okay, so number of grid lines in X direction and number of grid lines in Y direction. If I need to change the grid lines in Y direction, I can also change over that. Next, after going down, we can see the spacing of grids in X direction and Y direction. Spacing means the distance between each grids. So here it's shown over 8 meter. It's the spacing between here. There are 5 grids in X direction, right? So it's the spacing between each 2 grids. So if we need to change the spacing between this one in X direction, we can provide it over here 3 meter. In Y direction, if I need to change it, we can provide 4 meter over here. So this is the uniform grid spacing. Okay, now here shown over here is the grid labels. Grid labels means we can provide the labels of the grid. If we need to provide it in the alphabetical order, we can give it as A, B, C, D. If we need to provide it in the number order, we can provide the numerical order, we can provide it as 1, 2, 3, etc. So we can do it according to our preference. Okay, so that is the grid labels option. Next, we can go to the custom grid spacing. Custom grid spacing means every building will not be uniformly equal. In X direction, Y direction, we will not be providing equally spaced grids or equal number of grids. We will be changing the spacing. If it is 5 meter from if it's 5 meter from the first 2 grids, maybe it will be through 3 meter between the second 2 grids. So we need to provide a different custom grid spacing. For that, we are using the custom grid spacing option. For that, just tick this option and you can see the edit grid data option. Just go over here. After selecting the edit grid data, we can provide a grid system name. If I need to provide a grid system name, I can provide over here. I'm just providing grid 1. I'm just giving a name it as grid 1. Okay, I'm just giving a name as grid 1. And you can see over here, display grid data as ordinates and display grid data as spacing. We can provide it as 2 options. We can either provide the ordinates option or either we can provide the spacing option. See, you can see over here. If I provide the ordinate, we'll get it in the ordinates of the system. If I provide spacing, we'll get the spacing between 2 grids. I'm just going with the spacing option. Okay, and if I need to change the spacing, if I need to give the first spacing as 3.5, I can give it over here. And I need to give the second spacing, I need to give it as 4. See, I can change it over here. We can change it directly over here. If I need to provide 4.5 spacing, I can provide it over here. And for providing, we can change the spacing by just selecting the value and we can just edit the spacing. If I need to add an extra, grid, if I need to add an extra grid, okay, for providing, sorry, 1 minute. Okay. For providing extra grid, if I need to provide an extra grid, just click, see, you can see over here the add and delete option. If I need to delete a grid, you can just go over here, delete. See, now the grid is deleted. We have only the 3 grids. We can change the grid ID also. We can change the grid ID if I need to change this to BC. Just click the value and we can change the value. Okay, now I need to add. For adding a grid, we can just go with the add option. See, and here I'm just providing it as 3 meter. Like this, we can provide the custom grid spacing. See, in the last portion, the first, while providing the grid spacing, the last one should be 0. Okay, the last value should always be 0. Now, while going with the Y grid data, it's the same as shown over, shown like in the grid X grid spacing. Here is the X grid data, and here is over here is the Y grid data. Now, if I need to provide a Y grid spacing, I can provide it over here. Like if I need to change the value over here, I can change it like this. I can provide 3.5 meter. If I need to provide 3 meter, I can provide it here. Like this, we can change the value. We can customly, we itself can provide the value. I'm just deleting these data. And I'm giving this as 4.5 and just randomly giving it as 4.5. So like I said before, the last value should always be 0. Okay, so this is how we set the X grid data and Y grid data as a custom. I think you're going through it. Okay, and just clicking OK. So likewise, we can create a custom grid spacing. Okay, now next we need to provide the story dimensions. That is in the Z direction. For each story means for each levels or each floors, we can provide story data. So here also there's a symbol story data and custom story data. Symbol story data is a uniform method, and the custom story data we can customize and provide each story heights. So here you can see the number of stories, how much number of stories. If I need a 7 number of stories, I can provide 7 number of stories. Likewise, I can provide the number of stories over here. The typical story height, uniform story height of each floors can be provided over here. If I need a 5 meter story heights, we can provide typical story height over here. The bottom story height is the basement height, which is from the base level up to the up to the ground floor level. We can provide the bottom story height over here. The bottom story height and typical story height is different. Okay, I'll show it to you after this modeling. Now, for providing a custom story data, just click custom story data over here and go with edit story data. So you can see the story numbers shown over here. Before I provided 7 stories, right? Just okay. Here in symbol story data, I provided number of stories as 7. So that while selecting custom story data and going with edit story data, we can see the number of 7 actually. Okay. Just go with custom story data, edit story data. Okay. Next, we need to provide the story heights. For changing the story heights, likewise, you can change the story heights by default. You can change, just click the value and you can edit the value as you want. Okay, now if we need to change the story name also, you can change it over here. So let me, I'm adding a new story. For adding a new story, I need to add a new story to this list. For that, just click a story and right click. After right clicking, you can see the add story option. If I need to delete the story, you can delete the story over here. If I need to add the story, I can select the add story option. In the add story option, you can see 2 options over here. Keep existing story heights and keep existing story elevations. Keep existing story heights means it will be the same story height as provided before. Keep existing story elevations means it will be the same elevation value as provided before. Okay, that is the difference between the keep existing story heights and elevations. So I'm just giving the keep existing story heights option. So over here, you can see the story height what I need to provide. If I need to change the story height, I can change it over here. If I need to provide a 4 meter story height, I can change it over here. And here you can see the number of added stories, how much stories you need to add. If I need to add a 3 number of stories, we'll get a 3 number of stories. If I need to add a 4 number of stories, we'll get 4 number of stories accordingly. I need to just provide a single story. So I'm just giving it as number 1. And here the new story location, where I should add the story. Insert above story 4. If I need to insert it above the story 4, you can provide it above story 4. Otherwise, if I need to insert in between 2 and 3, so I can change it over here, insert above story 2. So the story 5 will be added over here. So that is the insert above story option, and just adding it above story 4 itself. Okay, then the replicate new story option. This option I will show you while doing the model. You will be more familiar with that. Now, right now, I'm just going with the none option. Okay, and I'm giving okay. See, now we can see a story is added over here. Okay, now I need to provide the heights. If I need to change the heights, I can change it over here. I'm just giving it a random heights. For the basement height, I'm just providing 0.9. Okay, before that, let me just give the names over here. I'm just giving it as plinth level. Okay, this is the plinth level, which is above the base level. So I'm just giving it as plinth. And this one, I'm naming it as ground floor roof. Okay, GF roof. I'm just giving it as GF roof that indicates ground floor roof. And here I'm providing it as first floor roof. Okay, and here I'm providing it as second floor roof. Okay, now I just need only up to second floor roof, and I'm just deleting this option. I'm going with the release story option, and I'm selecting the delete existing structured story. Okay, so I just need these many stories, and I have just gave the name. So for providing the basement height, that means the plinth height, I'm just giving a 0.9 meter height. Okay, other all stories, I'm just giving 3 meter height over here. Okay, now you can see the master story option. I'll get to you with that while doing the model. I'll show you what is the master story and all. But till now you will not get it. So I'll tell about that later. Okay, so I'm just clicking OK. So we have done the custom story data also. Now here we can see the add structural objects. So while for using the blank option, we are using the blank option when we are importing an AutoCAD or Revit file into this ETABS software. We use the blank option. But here we are modeling a structure. So for modeling a structure, we need to go with the grid only option. Okay, so I'm just selecting the grid only option and just giving OK. Okay. So as you can see over here, there are two windows. Here you can see is the plan view, and here you can see this the 3D view. This is just the grids that we have created. See, we can see the X data and Y data shown over here. These are the grids that we provided. Okay, now if I need to edit the grid after modeling, if I have finished all that quick templates, I have finished the model initialization and all, I need to edit the grid data. Here it is 7.5 meter, right? I don't need to provide 7.5 meter. I need to provide just 4.5 meter. I just need to provide it as 4.5 meter. So I need to edit the grid data. For that, just go with right click. After right clicking, you can see add or modify grids option. Just go with add or modify grids option. So you can see the two options. If I need to edit the story data, you can go over here, see modify or show story data. If I need to edit the grid data, you can see the modify or show grid system. So I need to edit the grid system over here. So I'm just going with modify or show grid system. So we will get that grid data before we selected a grid spacing data, right? Custom grid spacing. So that option will be open over here. I'm just giving it as display grid data spacing. And if I need to change it as 4.5, I can change it over here. And then just giving OK, and I'm giving it OK again. Now you can see, the model has changed. The grid data has changed. Likewise, we can edit the grid data after model initialization also. Okay, now let's get to the software. Here you can see over here is the menu bar shown over here. This in the top side, it's shown is the menu bar. In the bottom portion, it is shown is the quick access toolbar, and the left side also shown is the quick access toolbar. Okay, so you can see over here two views, plan view and a 3D view. If I need to change this view, if I need to change this 3D view into an elevation view, just select that window, and you can see over here the 3D, plan, and elevation. You can see the three options over here. I need to change this 3D view into an elevation view. Just select that 3D view and just go with elevation. So it will show, it will ask which elevation you need to see. So I'm just clicking the A option and like A grid, this grid. I need to see the elevation in this grid. Just click A and give apply and OK. See, you can see the elevation from here. This is the A grid elevation. Okay. Likewise, if I need to change it to 3D view, just click over here. Just click in 3D. You can see the 3D view over here. Okay. Similarly, if we need to change here, just click in the window and change it to elevation. If I need to change it to this one grid elevation, we just give apply. Okay, so we will get that elevation view over here. If I need to change it to plan view, if I need to change it back to a plan view, just click plan view over here. So you can see which floor I need to see. So these are the stories that I have provided. If I need to give the plinth, just apply. Okay, we'll get the plinth view plan. Okay, so this is just a basic. Now we need to do the model. Okay, now for creating the model, first we need to do is the define the material properties. We need to provide a material like concrete, or if I need to provide a rebar, we need to provide it as a material. So for providing materials, we'll just go with the define tab. You can see in the menu bar, you can see the define option over here. So after starting after the model initialization, providing the grids and story data, first before doing the model, we need to do a certain things that I'm saying right now. That is, first we need to provide the material properties. We need to define the material properties. So for that, just go in the define tab. After selecting the define tab, you can see over here is the material properties. See, you can see the material properties over here. Just go with that. After that, I need to add a new material. These are the materials that are already provided by ETABS, already provided by the software. But I need to add a new material. I need to add a new material like a concrete material. So for that, just go with add new material option. You can see over here. Just click add new material option. So here we can provide the region, material type, standard, and grade. So I'm just giving the region as India itself because I'm in India. I'm just giving it as India itself. We can change the material type. So I need to provide beam and column, right? For providing beam and column, we use the material concrete. So I'm changing the material type to concrete. So you can see our list of materials: concrete, aluminium, rebar, masonry, etc. So I'm just providing the concrete material. And standard, what type of standard code we are using? As I have selected India already, it will be India itself. Then the grade. We know the grade of concrete, right? M15 to M60 grade of concrete is shown over here. I'm just providing with M30 concrete. So this is how we add a new material property. Just click with OK. So we can give the material name over here. If I need to change the material name, I can change the material name over here. If I need to change the material type, it will also be shown over here. I'm just selecting it as concrete itself. And here is the specific weight density and specific mass density. If I need to change these values, if I know these values, I can change. As I am not having the data, I don't need to change. We can keep it as default and just go with OK. So we can see the created material over here, the M30 concrete material. Okay, so this is how we create a material. Now I have created the concrete material. Now I need to provide the reinforcement for the concrete, like beam and column also. For providing the reinforcement, we are providing rebars, right? So for that, I need to add a new material. I need to add a rebar material. For that, I'm just going with the add new material option. From the add new material option, and just the same, the region is same India itself. The material type, I need to change it as either steel. Sorry. Either I can select the steel option or I can select the rebar option. So I'm providing a rebar, so I'm just selecting the rebar option. So you can see the grade over here. The grade has changed. HYSD grade, mild grade. These are the grades that are already shown in this software. So I'm just going with the HYSD grade 415. Okay. So if I need to change the name, I can change the name over here, the material type, and the specific weight density and mass density. If I have the values, I can provide. Otherwise, just go with the default value because the software knows itself what weight density and mass density it would be. So we don't need to change the value. If we need to change the value, we can change it over here. If I need to change the value, we can change it over here. But I'm not changing the value. I'm just going with the default value. And I'm clicking OK. So you can see the two materials that I have created. This is how we create new material, or we define a material property in the software, and just going with OK. So I have provided the material. After defining the material properties, the next step we need to do is to define the section property. Now we have provided the material. We have provided concrete material and rebar material. Now we need to provide the section. Like for beam and column, what type of section we are giving? The section like depth and width. We need to provide the depth and width of beam and column, right? For that, we need to provide a section property. For that, I'm just going in the define tab. From the define tab, you can see section properties over here. So the section properties, you can see the frame sections, beam and columns and are frames, right? So it's a frame section property. I'm just going with the frame sections. In here, also, you can see the add new property option. These are the default properties that are created by the software. Now I need to add a new property. For that, go with the add new property option. While clicking the add new property option, a tab opens up. So here we can change the section shape. So we are creating a beam and column, right? If I need to provide a concrete rectangular, you can just drop down over here. These are the section shapes shown over here. Not only concrete, steel is also shown, joist is shown, other materials, other type of sections are also shown over here. Okay, if I need to provide a circular beam or column, you can see the concrete circle option over here. I'm just providing the concrete rectangle. If it's a trapezoid option, you can select the trapezoid option over here. There are various set of options shown over here. I'm just selecting the concrete rectangular option because I'm providing a rectangular section. Okay, just hold a minute, 1 minute. Okay, sorry. So let's continue. So we need to provide a rectangular section. So I'm just going with the concrete rectangular option. Okay. If either we can select the shapes over here, a default frequently used shape, a set of shapes are shown over here also. So you can see the concrete rectangular option over here also. If I need to select it over here, you can just select, just click it. After that, a tab will open up. So I need to provide a property name. So I'm providing two different sections for beam and column. Okay, so I'm just naming it as beam. First, I'm creating a beam section. And here you can see the material option. So while dropping this down, we can see the material that we have created before. See, the M30 material we have created before, right? That material will be shown over here. We can select it here. If I have forgot to create the material, if I didn't provide the material at first, we can click this three dots for adding a new material. See, define materials property tab has opened up. Here you can add the new material. If I have forgotten to add the material, 1 minute. Okay. If I have forgot to add the material, I can just click this three dots and we can add the new material over here. Okay. Next, while going down, we can, if we need to change the section shape, you can just drop down this option and we can change the section shape over here. I'm just going with the concrete rectangular option. And here you can change the depth and width. We can change the section dimensions. So for beam, I'm providing a depth of 250 mm and I'm providing a width of 200 mm. So you can see here, the section property shown here, we can see it over here. Okay, now I need to provide the rebar. Like I said before, we have also created the rebar material, HYSD 415. I need to provide that rebar material into this beam. So for that, you can see the reinforcement option over here. See, in this reinforcement option, just click modify or show rebar. So we need to specify it, column or beam, which is, we don't know. We have just named it as beam itself. We have just only named it as beam. We didn't give a property that it is a beam. So for that, we need to select it over here. So you can see the beam option over here. Just click it. After clicking the beam option, you can see the longitudinal bar and confinement bar. Here you can change the material before you have created. The HYSD 415 grade material will be shown over here. While clicking the three dots, if you have forgot to create the material, while clicking the three dots, you can add the new material. Okay, so these are the design data that we can provide for the top bars. We can provide the cover for the top bars and bottom bars. We can provide the reinforcement area overrides over here. If you need to change the value, you can change. I'm just going with the default value. Okay, and then just clicking OK. So you can see the section properties like okay, just giving OK and then click OK. So you can see the section property, the beam section property created over here. Next, I need to create a column. For that, I'm just going with add new property option. Same rectangular concrete column I am providing. I'm just clicking the rectangular option. After that, I'm naming it as column. Okay, here I'm changing the material as M30 material. Okay, like I said before. And here we can change the depth and width. So for column, I'm providing a 300 mm depth and 200 mm width. Okay, now I need to provide the rebar data. Just go with modify or show rebar. So here I'm just providing it as column itself. And here I need to change the longitudinal bars and confinement bars. Like I said before, if we need to change the design data or if we have a design values or design data, we can provide it over here. Otherwise, go with the default values and just click OK. So we have provided the column option, and I'm going with OK. So we have created the beam and column. Now I'm adding extra. I'm adding a plinth beam and plinth column, which is called pedestal. I'm adding a pedestal and plinth beam. I'm adding in this bottom portion. In the basement portion, we have provided a plinth, right? So in plinth, the data for the section property for beam and column will be different. It will be much more size than the ordinary beam and column. So I need to give a plinth beam and plinth column. Plinth column is called as pedestal. Okay, plinth beam and pedestal. So I need to add a new property. I'm just going with add new property, same concrete property I'm selecting, and I'm giving it to the name as plinth beam. Okay, I'm just giving the name as plinth beam. Here I'm changing the material as M30 material. So for the plinth beam, I'm providing the depth as 350 mm and width as 300 mm. Okay, now I'm going with the modify or show rebar option. Now I selected beam, so I need to click the beam option. I need to change the rebar data. I need to change it as HYSD 415, and I'm going with OK. And I'm clicking OK again. So that is how we create the plinth beam. Next, I need to provide the pedestal, which is known as plinth column. So for that, I'm adding the name property, same rectangular property I'm selecting, and I'm naming it as pedestal. I'm naming it as pedestal. Now I need to change the material as M30, and I'm providing the pedestal depth as 400 mm and width as 300 mm. Okay, now I need to provide the rebar option. For that, I'm just going with the column option itself. I need to give it as HYSD 415. If I have the design data, I can provide it over here. Otherwise, just go with OK. Now I have created the pedestal option. Just go with OK. So we have created beam, column, plinth beam, and pedestal. This is how we define a section property. We define a beam and column. Okay, now just go with OK. After doing this, first we added the materials. After that, we provided the section property. After providing these steps, we need to model the structure. So before modeling the structure, in the right side corner, the bottom right side corner, you can see over here an option, one story. Here, three options are here: one story, all stories, and similar stories. One story means if I'm doing a model, if I'm just creating any model over here, it will be affected only in a single story. This is in which level? This is in plinth level, right? Here you can see the plan view. It is in plinth level. If I need to change it to ground floor or second floor level, you can see the up arrow and down arrow over here. So plinth is the bottommost level. Now, if I need to go to the second floor roof, for that, just click this up arrow. So you can see the ground floor roof. Again, if I click the up arrow, you can see the first floor roof. Again, if I click the up arrow, you can see the second floor roof. Likewise, we can move the plan area. Okay. Likewise, we can move the story. If I need to move to the bottom portion, just click the move down in list. If I need to move to the upper portion, just click the move up in list option. Okay. Now, first of all, I'm just going to the plinth area. Okay. I'm just going to the plinth level plan. So in this single story, I have created let me get to the section properties. I have created pedestal and plinth beam, right? I'm just providing this in only a single story, right? Only in this story. Now, I'm just going with the plinth option. Okay, I'm just selecting the plinth level. Now, for drawing the beam and column, we need to go to the draw option. You can see the draw option in the menu bar. You can see the draw option over here. Just click this draw option. From the draw option, you can see draw beam or column or brace objects. You can see it over here. So first of all, I am providing the column. Okay, I'm selecting the column option. So in the column option, you can see the quick draw columns option and quick draw beams or columns. Just go with the quick draw columns option so that you can just place the column like this. You can just place the column in the script portion. Okay. Now, if this is in one story, just check it over here. It is in one story. So if I'm providing the column over here, see, it will be only in a single story. You can see the column is only in the single story itself. The column will move in the downward direction. Okay. Now, if I need to provide it to all stories, I need to provide the column throughout the all stories. Just change this data into all stories. After that, if I click over here, you can see the column is provided into all stories. If I click over here to see it's in the all stories. Okay, so that is the difference between one story and the all stories option. I'm just selecting this one and deleting. Okay, so deleted. Whatever I draw over here, it will automatically affect in the 3D view also. Okay, now one more option is over here, similar stories. So I'll get to that. For that, I'm just going to the story data. Edit. I'm just going to the edit the story data. Okay, before that, let me just first draw it in the one story. Like I said before, I have defined a section property for plinth, right? I have provided a plinth beam and pedestal. Let me model first of all that plinth beam and pedestal. For that, I am going to the draw option. First, I am providing the pedestal. Okay. First of all, I'm providing is the pedestal. So for pedestal is meant as column, right? For providing the pedestal, I'm going to the draw option. From the draw option, you can see draw beam or column or base objects. From that, just select the quick draw columns option. Okay. Now, this is just providing a column. Before that, we need to give the section property that we have defined before, right? We need to provide that section property. For that, the left side bottom portion, you can see the property over here. See, you can see the property option. By clicking this, you can just drop down. So after that, you can see the beam and column. See, these are the properties that we have created before. We have created the section properties before, right? These are the properties that is shown here. Now, here I'm providing the pedestal. That means the column. So for that, just click pedestal and you can provide it over here. See, as I have given one story, it will be given in one story only. I'm just providing it in the one story. Either we can provide it like this. By clicking in the each grid, we can provide it like this. Otherwise, just drag and select like this. So it will be provided as we have given the column option. It will be given in all the grid points. We can just drag and select and give the column. So this is just a quick method rather than giving it in the each grid points. See, now we have provided the pedestal option. Now we need to provide the plinth beam. Now I need to provide the plinth beam option over here. So for providing the plinth beam, I'm just going to the draw data. From draw data, just go into the draw beam or column or base objects itself. From here, you can see the quick draw beams or columns option. Okay, either you can select the draw beam option or quick draw beam option. If I'm selecting the draw beam option, I need to draw the beam like this. See, I need to draw the beams like this. I need to provide it like this. This is the draw beams option. Now, I'm just deleting this one. I'm just selecting it and deleting. I'll show you the quick draw beams option. I'm just selecting and deleting these beams. Okay. If I'm selecting the quick draw option, I'm going to the draw panel itself. From that, I'm selecting the quick draw beams or column option. From that, you can just click the grid. See, you can just click it over here like this. Like this, you can provide the beam. Okay, this also can be provided as a selection. I'll just show you that also. I'm just deleting these beams again. Okay, and I'm going with the draw tab. From the draw tab, you can just select the quick draw beams option. And I'm selecting it as a whole. See, like this also we can provide the beams. So this is how we model the beams and column. Okay, so now we have done it only in the basement portion, only in the plinth level. Okay, I need to provide it to the other area also. So here it is the same, right? Or in all the other portion, it is the same column and beam. So if I give all stories option, what will happen? It will go in all the stories, but I don't need to go to all the stories. I just need to start it from here. I need to provide the column from here to here. If I give the all story option, it will start from the basement up to top. But I don't need to give like that. I need to provide it from this plinth level to second floor roof. For that, we use the similar stories option. For before using the similar stories option, we need to set the similar stories. For that, I'm just right clicking. Like before we selected add or modify grids, right? I'm selecting the same add or modify grids option. Okay. So from here, you can see the story data. We need to edit the story data. I'm just going with modify or show story data. So this is the table we have seen before while doing the model initialization, right? So before I said I'll get to you with the master story option. I'll say it to you after, before while modeling. I'll say it to you. I just said it before, right? So here you can see the master story option. The master story is an option in which we can set a story as a main story. Okay, now if I'm setting this second floor roof as a master story, so you can select over here the second floor of which floor we can select it. We can select it over here and just giving the second floor roof as the master story. Okay. And here you can see the first floor roof, ground floor roof, and plinth level. These are similar to second floor roof. Okay, you can see if I'm setting the master story as second floor roof, we can only provide the similar to as second floor roof. Otherwise, we need to give none. None means it will not be similar. If I give it second floor roof, it will be similar to the second floor roof. Okay, so if I'm changing the data in second floor roof, it will automatically change in all these roofs. So like I said before, I need to provide columns and beams in ground floor roof, first floor roof, and second floor roof only. Okay, so I don't need to provide it in the plinth level. So in the plinth level, it is kept as second floor roof. So I need to change it as none. So the plinth level will not be affected. All other levels will be similar to the second floor roof. So if I change any data in these three roofs, it will automatically change into these three rows. That is the option we use for the similar stories option. If I'm setting a similar to option, we can provide a similar stories option, and we can only provide in those three stories. So this is why we set the master story and similar to stories. Okay, so I'm just going with OK, and I'm clicking OK again. Now I need to go to the first floor roof, sorry, ground floor roof. I can provide in any roof, ground floor roof or first floor roof or second floor roof. It will be all be the same. And I need to change it to similar stories. Then only it will be provided in the similar stories. I need to change it to similar stories option. After that, go to the draw option. From draw option, select a draw beam or column or brace objects. From that, select quick draw columns option. Okay. After selecting that, we need to change the property over here. From here, you need to change it as column. We need to change the property as column. Then I'm providing it like this. I'm selecting and providing it throughout. See, it has been in every column. It is just provided in the same similar stories itself. I was just provided in the ground floor roof, but it came in all the similar stories. Now I need to provide the beams, right? For similarly, I'm just selecting the draw beam or column option. From that, I'm selecting quick draw beams, and I'm changing the property over here as beam. Okay, and I need to provide it like this. Now we have created the whole structure. This is how we provide the beam and column. Okay, this is how we provide the beam and column option. Now I need to provide slab. Next, after providing the beam and column, we need to provide the slab, right? So for providing the slab, first I need to provide the slab section property. We have only given the section properties for beam and column. We have not given the slab section property. So for that, I need to give the slab sections. I don't need to add the material property because we already have added the M30 concrete material. So we don't need to add we don't need to add an extra material for the slab section, but we need to provide a slab section property. For that, I'm just going to define tab. From define tab, I'm selecting the section properties option. From here, I need to select the slab sections option. You can see over here is the slab sections option. I'm just selecting that. Okay. From here, we need to add the slab properties. So here you can see the add new property option. I need to add a new property, right? For that, I need to select the add new property option. So like we did before for adding the beam and column data, I'm just giving the property name. For that, I'm just giving it as slab portion. I'm just giving that name as slab. Here you can see the slab material. If I need to change the material, you can just drop down. So we can see the M30 material. Like I said, we need to provide the M30 material, right? So you can provide by giving it to the M30 material itself. If I have forgotten to add the material, just click this three dots so you can add the material again, like I said before itself. And here we need to change the modeling type. Here it is shown as shell thin, right? We use the shell thin option for sunshade, like sunshade portions, we use the shell thin option. For ordinary slab, we use the membrane option. We can use any options but for the ordinary slab, we prefer membrane option. While selecting the membrane option, you can see the use special one-way load distribution, right? One-way load distribution over here. So if we need to provide it as a one-way load, if we need to provide a one-way slab, just tick this option. If you need to give it as a two-way slab, just untick the option. So it will be automatically a two-way slab. Okay, so likewise, we can provide it as one-way slab or two-way slab. So the type is here. You can change the type. If I need to provide slab itself. If I need to change, if I need to give it as a wall and all, you can change it over here. And just going with the slab option itself. And thickness, I can change it. I'm just giving it as 150 mm thickness. Okay, and I'm giving it okay. So we have created a slab portion. Likewise, we have created the section property for slab. Now, like before we did, we need to draw the material. Just going with OK. So we have created the slab section property. Now I need to model it. For that, I am going with draw option. From draw option, don't select this. We have to go with the draw floor or wall objects. Over here, we have three options: draw floor or wall option, draw rectangular floor or wall option, and a quick draw floor or wall option. Okay, now if I'm selecting the draw floor or wall option, I need to draw it manually. I need to select the 4 grid points and I need to draw it manually from where I started and up to there. See, as I've given similar stories, it is created in similar stories. I have avoided this in similar stories, right? I have avoided the plinth portion. So that is the reason it is not shown in the plinth. So that is the reason why the slab is not created in the plinth level. Okay, so I'm just selecting this slab and deleting it. See, while selecting also, the selection is coming in the similar stories option, and I'm just deleting it. Okay, so I'm again providing the selecting the draw option. From that, I'm selecting draw floor or wall objects. From here, if I'm selecting the draw rectangular floor or wall, I need to draw a rectangular wall like this. I need to select one point, select an edge point, and drag to the opposite corner point and provide like this. Like this, I need to provide for providing a rectangular floor or wall. Okay. Now, next option is the quick draw floor or wall option. For that, I'm again going to the draw option. From draw option, I'm selecting the draw floor or wall objects. From here, I'm selecting the quick draw floor or wall. So before providing the floor, before providing the slab, I need to change the property, right? Before I have created the section property, the slab section property I have created. I need to provide that section property. So for that, you can see here the properties of objects in the left side corner. You can see the properties of the object. From here, we can change the property. So I'm just dropping this down so we can see the properties we have created. So I have created the slab property and just selecting slab. Okay, now I can just provide it like this. Just by clicking, I can provide it like this. Just I have selected the quick draw floor or wall option. So I'm just selecting this like twice. We can create the slab. Okay, I'm just deleting this created ones and I'm providing it to the all stories. This is in similar stories, right? So I'm just for providing it into the all stories option. I'm just changing here. From here, I'm changing it from similar stories to all stories option because I need to provide it to the plinth level also. So for that, I'm changing it from plinth level to all stories. Okay. Eitherwise, you can provide. If you need to provide it in the plinth level, you can give it into plinth level, or only if you need to provide it to the first floor, ground floor, and second floor, you can give it likewise also. I'm just going with the similar stories option itself. Okay, I'm just not giving it to the plinth level. I'm just going with the similar stories option itself. And I'm again selecting the draw option. On that, I'm selecting quick draw floor or wall option. And I'm changing the property. Before I have changed, so already the property is changed over here. I'm just clicking like this. So we can quickly draw the floor or wall by just clicking the slab portion. See. I'm just going by clicking like this. So by creating here, automatically the 3D model also is changing. So you can see for panning the 3D model, just click Shift button and just click the mouse scroll button. So you can pan the 3D view. Hold the Shift button, the keyboard, and hold the mouse scroll button. So you can pan the 3D view like this. Okay, so you can see the model I have created. So this is how we model slab, the beam, column, and slab in this software. Okay, so this is the modeling procedure. Now we need to provide load. Okay, after modeling, first what we did, first we gave the material properties like concrete and rebar properties. After that, we gave the section properties. After providing the section properties, we modeled beam, column, and slab. Okay, right now we are standing here. Next, we need to give is the load. We need to assign the loads. So we know there are two loads, mainly dead load and live load. There are other loads also. There are seismic load, wind load, etc. Right now, I'm just going with the dead load and live load. So for that, in dead load condition, we have the self-weight load. In ETABS software, we don't need to provide the self-weight load extra. The self-weight is already added into this. So we don't need to provide the self-weight load by ourselves. We need to provide the other dead loads that are applicable in this structure. Okay, so for that, I'm just giving the wall load. I'm first considering the wall load. In the dead load, I'm considering the wall load. So where all the wall will be here in this plinth level, then the ground floor roof, and first floor roof. In second floor roof, we don't give the wall. We only give wall in these portions. In second floor roof, we give parapet wall. Okay, so here we are giving the ordinary wall in the plinth level, then the ground floor roof and the first floor roof. So for that, we need to calculate the load. So for calculating load, there is an equation. There is an equation for calculating a load. Whole load into density. Whole volume, sorry, whole load, not whole load, whole volume. The whole volume of the structure into density is how we calculate the load that is applied to this structure. So we need to provide the wall load, right? We need to give the wall load. So we need to calculate the volume of the wall. So how we calculate the volume? Length into breadth into height. Okay, so length into breadth into height option we are using. So we are giving the unit length. We cannot give the length of each beam or column because the length is variable. The length is different for each data. Here it is 4 meter, then it is 3.5 meter. So we need to provide each and every load additionally. That is difficult. That is not practical. So we can give a unit length, which will be uniformly acting throughout. Okay, so I'm just giving a unit length 1. Okay, 1 into, that means length into. Now I need to provide the breadth. What is the width? Breadth or width? What is the width of a wall? An ordinary wall width is 23 centimeter, right? I'm calculating it in meters, so I'm just giving it as 0.23. So this is the width of the wall into. Now I need to provide the height. What is the story height we have provided? If you are having a confusion, just right click, go to the add or modify grids. From modify or show story data, you can see the story height. What we have provided, 3 meter height is the story height we have provided. Okay, so I'm taking the calculator again. I'm giving it as into. I'm not going with 3 meter height. It is because we have provided a beam, right? What was the beam depth we have provided? We have provided a 250 mm beam depth. So the beam will be in that portion, right? If I'm selecting the structure, see, if I'm just see this plinth level. If the beam is over here, this is the total 3 meter height. This 3 meter height is up to this grid. So if at 0.25 meter, sorry, 0.25 mm depth beam is provided over here, the grid, the story height will be different, right? The total height is 3, then a depth of 0.25 mm beam will be here. So it will be total 3 meter minus depth of the beam 0.25 meter. I think you got it. Okay, so we need to calculate likewise. So 3 minus 0.25 meter means 2.75 meter. I think you got how we calculated the height. Okay, so likewise, we have calculated the volume. Now we need to provide the density. So for the density condition, in brick, we are taking it as 25, I think it's 25 something, or yeah, 25 something. Here I'm providing the density as 20 and selecting, okay, going with the density option as 20 and just clicking equal. So this is the load we have got, 12.65. So the wall load in this structure is 12.65. So we need to provide that wall load. So for that, for assigning the load, first we need to select the beams. Okay, for selecting the beams, what all portion beams we need to select? We need to select the plinth level beam, the first floor roof, and the ground floor roof and the first floor roof. We need to exclude the second floor roof. So for that, we need to go with which option? We need to go with the similar story option. For that, just right click, add or modify grids. From modify or show story data, we need to change the story data over here. So we need to set the similarity, right? I said we need to give the load in plinth level, ground floor roof and first floor roof. So we need the selection only in these 3 levels. So for that, I'm setting this first floor roof as the master story. I'm just selecting this as the master story. See, and I'm setting this ground floor roof similar to first floor roof, and plinth level also I'm setting it as similar to first floor roof. Now these 3 floors are similar. So if I'm giving a load, the load will be applied in these 3 floors only, because I have set the similar to. If I need to off the master story, you can off over here. Otherwise, just go with yes also, but no problem because it is already similar to first floor roof itself. So if I give a difference, it will not affect the second floor roof. Okay, I'm just clicking OK. Then I'm going with OK again. After that, I need to provide the load, right? So this is the ground floor roof, no problem. Just select the beams and just dragging and selecting all the beams in this portion. See, the plinth level is selected, ground floor is selected, and the first floor is selected, excluding the second floor. Okay, so that is the sim. I need to assign the load. For that, I need to go with the assign option. You can see the assign option over here. Select this assign option. After assign option, this is beam, right? Either we can select for the whole beams, otherwise you can select if the wall will not be throughout the whole beams, right? It will only be in some portion. If I need to select only that portion, you can select like that. But here I'm just selecting the whole structure and I'm going with the assign option. From assign option, you can see the beam and column are, sorry, the beam and column are frames, right? You can see the frame loads option over here. See, not this frame loads option. From the assign tab, select the frame loads option. So wall load is a distributed load, right? It's a UDL load. So I need to select the distributed load option. So you can see the load pattern name. It's shown as dead load. So wall load is a dead load, right? It is not a live load. So it's a dead load. You can change the loads over here. See, dead load and live load is given over here. And just selecting the dead load option. And here you can select the force moment, which we want. We can select that. And here is the add to existing loads, replace existing loads, and deleting existing loads. We need to add the load. So just go with add to existing loads option. So here we need to provide the load. What was the load we calculated? It was 12.65 kilonewton per meter, right? This was the load we calculated, and just click apply. See, you can see the load applied over here. See, the 12.65 kilonewton load is applied over here. So you can see the load applied over here. But if you want to see whether it is applied or not, just select a beam. Here we have applied, right? Just select that beam and just right click. After right clicking, you can see the loads. See, a uniform force load of 12.65 kilonewton per meter is assigned. Just select that beam. For selecting a single selection, just go with one story option. After that, just select that beam and just right click. So you can see the loads. See, the uniform force is 12.65 kilonewton meter. This is the load we have added. So that load will be shown over here. Okay. Likewise, we can see whether load is applied or not. So we have given the wall load. So wall load we have given up to first floor roof only. Now we need to provide the parapet wall load in the second floor roof. So for providing the second parapet wall, we need to calculate the parapet wall load. So I'm taking the calculator again. Now I need to calculate the parapet wall load. So as like I said before, I'm selecting the unit length, that is 1. I'm giving it as unit length 1 into. Now I need to give the width of the parapet wall. So the parapet wall width will be 10 centimeter, likewise only. So this 0.1 meter into 0.1 meter width into height. Height also I'm just giving a 1 meter height. So I'm giving it as 1. Now into. After that, we need to multiply it with the density. So I'm providing the density as 20. 2 kilonewton. 2 kilonewton per meter is the parapet wall load we have got. Now I need to change the plan view. This is the ground floor roof. See, this is the ground floor roof shown over here. I need to provide the load into the second floor roof only. For that, just go to the second floor roof by clicking this move up in list option. See, we have not provided the load in second floor roof, so that it's not showing. Now I need to provide the parapet wall. So the parapet wall will only be in the sides. So just select the side beams. Just select the side beams like this. We don't need to we don't need to hold the control option. We can directly just select the beams. See, I'm just selecting the outer beams. Just the outer beams over here. Now, after selecting the beams, now we need to provide the load. For that, I'm going to the assign. From the assign, before I have selected frame loads, same frame loads option. From that, I'm selecting the distributed load option. And here I'm providing the dead load itself. I'm selecting the add to existing load options. So 2 kilonewton per meter was the parapet wall load, right? I'm just giving it as 2 kilonewton per meter, going with apply. Okay. See, you can see the load applied over here. So this is how we apply the load, dead load. Now we have provided up to the parapet wall load. Now we need to provide the slab load. We need to provide these slab loads. Okay. So for providing the slab loads, first we need to select the slabs. So for selecting the slabs, I'm just going with, I'm giving the slab load as 1 kilonewton per meter. Okay. I'm giving the slab load in first floor roof and ground floor roof as 1 kilonewton per meter and second floor roof as 1.5 kilonewton per meter. I'm not just assuming it is from a code IS 456, I think. Yeah, from that code, it is the value given for what live load we need to provide it in the slabs. Okay, so I'm just giving a 1 kilonewton per meter, sorry, 2 kilonewton per meter load for the slabs in ground floor roof and first floor roof. And I'm providing a 1.5 kilonewton per meter load in the second floor roof. So I'm just selecting, going with the first floor roof option. From here, I need to select the slabs. So for that, I'm just selecting the slabs like this. Before that, set to similar stories option. If the similar stories option is not shown over here because it is the issue of the software, just save the file. First, just save the file. Let's give it a save as and just give it a name. I'm just giving it as slab model. I'm just giving a random name. I'm saving it as a desktop. Saving, just close the model and open the model again. It is a software issue. Opening the model again. Okay. So now you can see the story option. So I'm setting it as similar stories, and I'm not providing it in the second floor roof, right? So I'm providing dead load in these two roofs and a live load in the second floor roof. Okay. So I'll show the live load option also. So first of all, I'm providing the dead load in the first floor roof and the ground floor roof and the first floor roof. So I'm selecting the first floor roof option and I'm selecting the slabs. See, as I have set it into the similar stories option, only the slabs and the similar stories options, only the slabs and the similar stories will be selected. So I have selected the slabs. After that, I need to go to the assign option. From the assign option, we have to select the shell loads option. This is the load we are applying for the slabs. On the shell load option, select uniform option as we are providing the uniform load. Now change the load pattern name. I'm giving it as dead load itself, and I'm giving a dead load of 2 kilonewton per meter square. Go with that to existing loads option, apply. Okay. Now we have provided the slab load. Okay. Now I need to provide a live load for the second floor roof. So I'm just going to the second floor roof. After that, I'm selecting it as one story, and I'm selecting only the slabs in that story. Okay. I selected the slabs in that story. Here I'm providing the live load. Okay. So I'm selecting the assign option. For the assign option, selecting the shell loads option. From that, I'm giving the uniform option. So I'm changing it as live load. Okay. And I'm giving a live load of 1.5 kilonewton per meter square and adding it to the existing loads. Apply. Okay. So in the ground floor roof and the first floor roof, I gave 2 kilonewton per meter square, right? It is because I'm giving the 2 kilonewton because I'm adding the floor finish load also. That's the reason I have added 2 kilonewton per meter square in the ground floor roof and the first floor roof. In the second floor roof, there is no floor finish. It is on the roof portion, right? It is in the topmost portion. The topmost portion, we won't provide the floor finish. We don't provide tile or anything. So that's the reason I'm providing only the live load in this portion, and I'm including floor finish in the bottom portion. So this is how we provide the loads. Okay. Likewise, we can provide wind load, seismic load, and etc. Okay. So this is how we provide dead load and live load. These are the basic loads we can provide in this. Now, I need to provide a load combination. I need to combine these loads. There's a load combination, 1.5 dead load plus live load. That is 1.5 is the factor and dead load plus live load is the load combination. So for providing a load combination, Load combination is different from loads because the loads can give an accurate value, okay? But while providing a load combination, we'll get a more accurate value than just providing loads. So if I need to provide a load combination, just go to the define option. From define option, you can see the load combinations option over here. See, you can see the load combinations option. Just click it. We need to add a new combo, right? So just click add new combo option. I'm just naming it as 1.5. Like I said, 1.5 dead load plus live load. I'm adding this combination. Okay, only this combination. I'm just showing this combination. We can add as many combinations we need. I'm just adding this 1.5 dead load plus live load. So you can see the load over here, the dead load we have provided. I'm adding again. I need to provide the live load also. So here I need to change it as live load. So dead load and live load. What is the scale factor? 1.5 is the scale factor. So just click that scale factor option and change it to 1.5. Here also I'm changing it to 1.5. And I'm going with OK. After that, you can see the 1.5 dead load plus live load combination is added. If I need to add an extra combination, if I need to add new combo, just click with add new combo. You can add new combo. How much you want, you can add it. I'm only adding this 1.5 dead load plus live load combination. This is how we provide the load combination. Okay, and then just clicking OK. Okay, after clicking OK, we can't change the we won't see the any changes in the model. Now we need to analyze the model. After providing the load, we need to analyze the model. Before analyzing the model, we need to check the model whether any errors are there in modeling. We need to check first of all. For that, just go to the analyze option. From the analyze option, you can see check model option. See, you can see the check model option over here. Just click check model. After that, we need to check throughout. We need to check everything. Just click select or deselect all and just click OK. So the software will run and check over the model if any errors are there. We can see whether errors are there or not. Okay, so there are no warning messages. See, the model has been checked. No warning messages were generated, so no problem. Just close it. Now we need to analyze. For that, either you can go to the analyze option and select run analysis, or here is in the quick access toolbar, you can see the run analysis option. Either we can go to the analyze option and select run analysis, or you can select this run analysis option. I'm just selecting this run analysis option. So we need to save the model. So I'm just saving it in the desktop itself. Okay. So the software is running. The software is analyzing the model. See, you can see the deformed shape of the 3D model. You can see in the 3D model the deformed shape. While just placing the joint, we can see the values also. See, UX value, UY, and UZ value, RX, RY, and RZ value can also be seen. Just place in the joint. Just no need to click. Just place in the joint option so you can see the data. Okay. Now, if you need to see the uniform load like that, you need to see the UDL or UDL or SFD, like shear force diagram or bending moment diagram. Just click that model. After that, you can see over here the display frame load assigns. Sorry, just click that beam, whatever you need, and just go with the display frame option. Just go in the display options. You can see the sorry, 1 minute. Okay. Yeah, over here you can see display frame options. From here, if we need to see the UDL or bending moment diagram. Sorry, not UDL. The bending moment diagram or shear force diagram. Just click this option, display frame or PRS spandrel option. Just click that option. After clicking this option, you can see if I need to see the moment. If I need to see this moment, just click apply. So you can see the moment. See, if I need to select this moment 3 option, if I select that option, you can see the moment over here. If I need to see the shear force diagram, just click this and you can see the shear force diagram also. You can likewise see the shear force diagram. If I need to see the maximum bending moment or maximum shear force, just select that beam. After selecting, just right click. So you can see the equivalent loads, shear, moment, everything will be shown over here. So this is the load case. Dead load and live load will be shown over here. We have provided a load combination, right? If we need to see the load combination data, just click this load combination. So you can see the load combination, shear force, bending moment, and deflection. Likewise, we can see the data. If I select this, you can see a green light, right? If I select the green line, by selecting this green line, you can move through the values. See, we can see the value over here. What is the shear force value? 1.4735 kilonewton. If I move throughout, you can see the value changing. See, you can see that not only shear force, the moment also and the deflection also will be shown. Okay. Likewise, we can select the load case option or the load combination option, whatever we need. So this is how we analyze a model. Okay. After analyzing now, we need to provide the design. We need to do the design. For designing, we need to go with the design option. So by selecting the design option, you can see the concrete frame design option. You need to design the concrete frames, right? So for that, go with the concrete frame design option and go with view or revise preferences. So you can see over here, the design code is IS456. Before in the model initialization, we gave IS456, right? So it will be default IS456. If it is kept as different, we need to change it as IS456. Then if we need to change the values, if we need to change any data, you can just click over here and change the values. I'm not changing any values. I'm just giving it as default values itself, and I'm just going with OK. After viewing or revising the preferences, next we need to do is the design. So for that, go to the design option. From the concrete frame design option, select start design or check. You can see start design or check option over here. Just click the start design or check option. See, as we have selected only this beam, the design has been given only in this beam itself. Before we selected to this beam for seeing the bending moment and shear force, right? So only in this beam it is shown. If I need to see the design data of all the beams, select all stories. And what we need to do is that select all the beams. See, now all the beams and columns are selected. In all the stories, the beams and columns are selected. After that, go with the design option. Concrete frame or design. From that, select the start design or check. See, now we can see the design data. See, here it is shown OS, overstraining. See, it is an error that is shown. That is the error that has been shown over here. The overstraining is shown is the error. Just by right clicking, you can see the top steel, bottom steel, all data will be shown over here. Design details will be shown over here. See, while clicking the details, you cannot see, I'll just zoom it. So you can see the beam element details, section properties, design code parameters, force and moments, design moments, everything will be shown in this design data. For selecting that, just select that beam and right click. After right clicking, you can see the details option over here. From the details option, you can see the reinforcement. We gave the reinforcement, right? We gave the rebar. The rebars will be shown. So this is how we design the model. Okay. After designing, now if I need to get a report, I need a report for providing it to the client. And if I need a report, just in the Model Explorer tab, you can see the reports option over here. See, you can see the reports option. Just select that reports option. After that, you can see the project report. Just double click that project report. It will take some time. 1 minute. Just loading. Just hold a minute. See, you can see that project report. The ETABS software itself has created a project report. You can see the list of tables, the structure data, grid data, everything will be shown over here. See what all we have done here, all the data will be given over here. It will be a detailed report. It is not a summary report. It is a detailed report. All the data, all the design data, all the analysis data, everything will be shown over here. Likewise, we can create a report. Now, if I need to export this report, I need to create it as a PDF. Just click this print report option. While clicking the print report option, we can see it is Microsoft printed to PDF. I need all the pages. Okay, and just clicking it OK. Just loading a minute. Okay. So I'm saving it in the desktop itself. I'm just giving a name as a slab report. I'm just giving it, I'm giving a random name. I'm just naming this. So the page, I think total 177 pages are there. So every page will be added. Yeah, 171 pages. Okay. So you can see the slab report. The PDF report I have exported is shown over here. For select this slab report, you can see the PDF. See. You can see that PDF, all the data, what all we have done, all the data will be shown in this report. All the load case definitions, see the dead load, live load, all the load case options. See, we have added the load combinations also, right? See the dead load, live load combination. Every data, each and every data will be shown in this report. This is how we generate a report from ETABS software. So this is how we do the structural analysis and design using the ETABS software. Okay, now let's get back to our presentation. Okay, now let's get back to our presentation. So next, what are the advantages of the ETABS software? So it is a graphic input and modification for easy and quick model creation for any type of structure. The creation of 3D model with the utilization of plan views and elevations. It's a very easy method. The 3D model of any kind of complex structure can be created easily. The model editing is very simple. The grid data, story data all we provided are very simple to add and edit. Any item such as beam, column, slab, wall, etc. can be quickly created with just one mouse click. Okay. So these are the advantages of ETABS software. Now, disadvantages. What are the disadvantages? So as you can see, it is not free. It is very expensive to purchase. As the ETABS software is very expensive. It is a structural designing software, right? So it is very expensive to purchase. It is not always accurate, as we provided, like we saw over here, right? The overstraining was shown because it is not always accurate. It will majorly give false results. So these are the disadvantages of the ETABS. Okay, so I'm just winding up my session. This is the overall data of the structural analysis and design. So this is the job roles that can be. Let me get. I'll tell about the job roles also. Structural engineer, which to design and analyze the structure. The construction engineer, which helps them to plan and oversee the construction of a project. The project manager, which helps them to manage a project from start to finish, and a quality assurance engineer. These are the job roles that can be got by learning ETABS software. Okay. The quality assurance engineer helps them to ensure that a building meets the proper standards and meets all safety requirements. That is the role of the quality assurance engineer. Okay, so I'm winding up my session.